Hi everyone, I am Yuanbo Xiangli, and here I'm going to talk you through our work called Doppelgangers++. This is a joint work with Ruojing, Hanyu, Jeffrey, and Noah. In real world, accurate 3D reconstruction is frequently hindered by visual aliasing, where visually similar but distinct surfaces are incorrectly matched. These superior matches distort the structural motion process, leading to misplaced model elements and reduced accuracy. We name this problem as doppelgangers. When dealing with such doppelganger pairs, pervasive local feature matching methods struggle a lot. For example, this is Belvedere Palace, and these two images here are the frontal and back side of the palace. They look very similar, but are different facades. If we want to reconstruct Belvedere palaces from internet photos with varying camera distance and viewing angles, this pair of images will cause problem. As an example, advanced feature matching method like white glue here yields 579 matches in this pair of frontal and back facade images compared to 420 matches in truly matched pairs. Similar things can also happen to structured and dense captures, like Temple of Heaven here. Light glue in this case gives us 884 matches in doppelganger pair compared to 930 matches in a truly matched pair. Previous work formulated this as a binary classification problem. That is, given a pair of images, determine whether they are a doppelganger pair or a truly matched pair. They train this classifier with data crowd from Wikimedia Commons, which mainly contains landmarks, where categories like from south from north are used to distinguish them. They constructed a doppelganger dataset from this and trained a CNN-based classifier that takes key points and after matches and output a score between 0 and 1. Despite their method demonstrated a certain degree of improvements on disambiguating scenes, especially landmarks, we found several limitations. First, previous method is not distinctive enough, so it struggles with subtle geometric and appearance differences. Secondly, this classifier is sensitive to threshold, meaning that small changes in threshold can cause misclassification, and we need to manually tune threshold for different scenes. Lastly, because of the restriction of the training data, it only works well on landmarks and cannot generalize to everyday scenes. So we made improvements from measuring two aspects, expanding the training data, and designing better classifier. To start with, we enriched the training data to include various types of daily life scenes. We introduced Wisdom Scenes dataset, which is collected worldwide. These data were collected with GPS and IMU metadata. We developed a series of rules to compare the distance and viewing directions between pairs of images, and mined about 53K doppelganger and true matching pairs. They serve as a complementary to the notable landmark available on the Wikicommon dataset. And different from prior work, which explicitly extracts key points and matches, we leveraged the robust multi-level geometric feature of a SOTA pairwise image matching model, which is master, and trained a transformer-based classification head to distinguish these pairs. During training, we freeze the master backbone and only train the classification head. The classifier can then be seamlessly integrated into SFM or master SFM pipeline and directly work on their scene graph. We also noticed that there is no reliable benchmarking method for evaluating the accuracy and correctness of reconstruction results, especially in terms of how well they address the doppelganger issue. Therefore, we propose a comprehensive evaluation protocol to assess both reconstruction correctness and completeness. So essentially, this involves registering geotech images to the SFM results and compare how well the registered camera aligns with their actual geolocation. We compute a inlier ratio as an indicator of how well the registered camera aligns with their geolocation, and higher inlier ratio means higher accuracy. To evaluate our method, we performed two tests. One is pairwise visual disambiguation. In this task, our method exhibits higher average accuracy, better distinctiveness, and is more generalized on out-of-domain datasets. Another test is structural motion reconstruction disambiguation. So here we report the inlier ratio metric and compare the completeness of reconstruction results. Experiments show that ours constantly outperform previous method in these two metrics and also sometimes reduce oversplit components and also requires less threshold tuning. There are some more results on our project page. Please check them out. Thank you.